Question B wants us to prove that cos of theta over sine 2 theta minus cos 2 theta over 2 sine theta is equal to sine of theta. If we look at cos of 2 theta and sine of 2 theta, we will see that these are compound angles and we have a variety of identities, especially for cos, that we can use to substitute for these. So let us start with our left-hand side. And we have cos of theta here, where there was sine of 2 theta. We will substitute with the identity of 2 sine theta, cos theta. For our cos 2 theta, we will choose the cos squared theta minus sine squared theta over 2 sine theta. Here, the cos theta can cancel that cos theta, and we will be left with 1 over 2 sine theta minus cos squared theta minus sine squared theta over 2 sine theta. We can see that our fractions are to the same denominator, so we will simply just have 2 sine theta over 1 minus, let's make sure to put that in bracket, cos squared theta minus sine of theta. Then we can go ahead and multiply out with that negative. We'll get minus cos squared theta minus, plus sine squared theta over 2 sine theta. Now we know that cos squared theta plus sine squared theta gives us 1, and sine squared theta will now be equals to 1 minus cos squared theta, which is exactly what we have over here. So we can replace that with just sine squared theta. We will have sine squared theta plus sine squared theta over 2 sine theta. We will add these two together. We will get 2 sine squared theta over sine squared theta. And one of our, sorry, the 2 is actually over here. There's no square over there, just certain. 1 of our sine theta will cancel with 1 of the 2 that we have here, and just 1 of the 2, just 1 of the 2 there. So we'll be left with, and again, that 2 will cancel out with that 2, and we'll just be left with sine theta, which is equals to the right hand side. And there is our right hand side.